Hello everyone. So today we are solving the problem of the day from Geek for Geeks, which is shortest distance in a binary maze. So we are given an n cross m matrix grid where each element can either contain 0 or 1. We have to find the shortest distance between a given source cell to a destination cell. The main point here is that we can only choose the cells which has value 1 in it. If we don't find any such path, then we are going to return -1 as it is stated here. So now we have only four directions to move on. We can move to up, down, left or right direction. And here we have stated the example in which we are currently at the source, which is this point 0, 1, and we have to go to destination, which is this point. As we know the main point of this question, we can only choose the cell which has 1 in it. So we can choose any of the path which only contains 1. Now we go to the solution part, and here I've used the solution by BFS algorithm, which is particularly used in graph, and it is basic implementation of BFS algorithm in which we are at a particular point and we are moving to the four directions and marking the particular point as visited. So now let's go to the problem solution. So as I have taken an integer answer which contains the integer maximum value, and now at this point here we are performing the BFS algorithm, and after the BFS algorithm if the answer is not int max, then we are returning the answer, and if it is int max then we don't have any such path which contains only 1. So here we are returning -1. So now let's go to the BFS algorithm which we have implemented. So here we have implemented the BFS algorithm. So here in C contains the destination first, like it contains the row of the destination. This contains the destiny column of the destination, and I've created a visited 2D vector which contains whether the particular cell is visited or not. This contains the number of row in the visited or the whole vector. This contains the number of columns. Now, as in every BFS algorithm, we here also use a queue. Here we are using a special queue in which we are using a pair of integer comma pair of integer comma integer. So this stores in the format distance comma row comma column. So this is the format in which this is storing. Now in this point we are pushing 0 comma 8 0 comma s, where 0 is the distance of the source from source. So like we are currently at the source, and its distance from source will be 0 now. So this is the basic thing, and now we are doing the basic BFS algorithm. Here we are storing q dot front in IT, and then we proceed and we check whether if we get the first row and column equal to the destination, then we are storing this in answer and returning. Here we are checking for the 4 points. This is for right. If we have some valid cells in the right, then we are going to choose this one. If we have valid cells in the down direction, then we are going to choose this one. If we have valid cells in the left direction, then we are going to choose this one. And if we have valid cells in the bottom direction, then we are going to choose this one. In every step we are doing distance plus 1. So this distance plus 1 is basically that from that cell, when we are moving to the next cell, we are increasing the distance by 1. So we are increasing the distance plus 1 here. And now as we can see that this is basic code of BFS algorithm. It just uses the only difference that we have here is that we are using pair of integer comma pair of integer comma integer. This one is for the distance, this is for row, this is for column. That's the only difference here, and the rest of the thing is same. And at this point we are returning when the at the first instance, when we are finding something that is equal to the destination, it is always going to be the minimum answer. So we are returning at that point only. We are not going to check for the further recursions. We are not going to check it. So this is the solution for the question that we were given, shortest distance in a binary maze. Thank you.